This lesson is about complex fractions. A complex fraction is a fraction whose numerator, denominator, or both contain fractions. And here we have some examples. 1/2 over 2, 5 over 2/7, 2 3/4 over 1/8. We want to simplify complex fractions by having the fractions in the numerator or the denominator quote-unquote disappear. And we do this by multiplying both the numerator and the denominator by the reciprocal of whatever fraction we are trying to eliminate or simplify. So, for example, to simplify 1/3 over 2, we're going to multiply this numerator by 3 over 1, which is the reciprocal of 1/3. And we're also going to multiply our denominator by 3 over 1, because 3 over 1 over 3 over 1 is equivalent to 1. So when we do this, our numerator becomes 1, and our denominator becomes 6. Thus, 1/3 over 2 simplifies to 1/6. Let's take a look at our second fraction, 5 over 2/7. So the reciprocal of 2 over 7, our fraction in the denominator, is 7 over 2. So we're going to multiply the numerator and the denominator of our fraction by 7/2 over 7/2. This becomes 1, and we will get 35 over 2 over 1. And so we have simplified our fraction. A complex rational expression has a rational expression in the numerator, denominator, or both, just like our complex fractions, but instead we've got variables. The process for simplifying these complex rational expressions is very similar to the process we used to simplifying complex fractions. What we're going to do is we're going to multiply the numerator and the denominator of the fraction by the reciprocal of the rational expression we are trying to simplify. So, for example, in our first complex rational expression, 1 over a, we're going to multiply both the bottom and the top of the fraction by a over 1, which is the reciprocal of 1 over a. When we do this, our numerator becomes 1, and our denominator becomes a squared. And so now our complex rational expression has been simplified. Let's take a look at the second example, x plus 3 over 1 over x. So I've got x plus 3 in my numerator, 1 over x in my denominator. The reciprocal of 1 over x is x over 1. So I'm going to multiply both the numerator and the denominator by x over 1. Now my denominator becomes 1, and I've got x times x plus 3, or x squared plus 3x. And now my complex rational expression has been simplified. And of course, you don't want to forget to include your restrictions on the denominator, on the variable, sorry. So for our first example, a cannot equal 0. And for our second example, x cannot equal 0. Don't forget that, or your answer isn't complete. Let's take a look at how we would simplify this rational expression. 1 plus 1 over b minus 2b squared over 1 minus 1b. 1 over b, sorry. So the first thing we need to do is to find an LCD, a lowest common denominator, for the numerator and for the denominator. And I see for the numerator my lowest common denominator will be b squared. So I need to put my entire numerator over b squared. And my lowest common denominator in the denominator is going to be b. So I need my entire denominator over b. So here we go. Let's take a look at what's going to happen. I have to multiply 1 by b squared over b squared. I need to multiply 1 over b by b over b. And 2 over b squared is already over b squared, so I don't need to do anything with that. Now, taking a look at my denominator, I need to multiply 1 by b over b, and 1 over b is already over that common denominator, so I don't need to do anything about it. So let's just simplify this, shall we? B squared over b squared times 1 is just b squared over b squared. B over b times 1 over b is b over b squared minus 2b squared. So now everything in my numerator is over the same denominator. And now let's take a look at this. So I've got b over b minus 1 over b. So here we go. Let's simplify a little further. So I've got b squared plus b minus 2 over b squared over b minus 1 over b. Now what we're going to do is we're going to multiply the numerator and the denominator of this expression by the reciprocal of this denominator. So here we go. We're multiplying the whole thing by b over b minus 1 down here, b over b minus 1. Let's move the screen up a little so we have some more room to work and finish our multiplication. So here, this b and this b squared can cancel a little, so I'm left with b here. This entire denominator becomes 1. So now what I'm left with is b squared plus b minus 2 over b minus 1. But I can factor that numerator into b plus 2 times b minus 1 over b minus 1. So therefore I can reduce by b minus 1 over b minus 1, because that's 1. And I am left with b plus 2. Am I finished? You're right, I'm not. I need to list my restrictions. What can b not be equal to? Well, let's go back to the beginning of the problem. B cannot be 0 over here or over here. Is there anything else that's ended up in a denominator that b cannot be? B cannot be. Well, if I look over here where I've got b minus 1, if b is equal to 1, then this expression would be equal to 0, so b cannot be equal to 1 as well. And so here is my solution. B plus 2, restrictions on b, cannot be equal to 0 or 1. Let's look at one more example. Okay, so here's my example. B over 10 plus 1/2 over b squared over 25 minus 1. So again, the first thing I need to do is to get a lowest common denominator for the numerator and for the denominator. Well, the lowest common denominator for my numerator is clearly going to be 10. And my lowest common denominator for the denominator is clearly going to be 25. So I'm going to go ahead and start simplifying. B over 10 is already over 10, so I'm just going to multiply 1/2 by 5 over 5. So I'll get b over 10 plus 5 over 10. B squared over 25 is obviously over 25, so I'm going to multiply 1 by 25 over 25. So I'll get b squared over 25 minus 25 over 25. And now I can start simplifying. I've got b plus 5 over 10 in my numerator, b squared minus 25 over 25 in my denominator. And I've already noticed that b squared minus 25 is the difference of two perfect squares, which is equal to b plus 5 and b minus 5. Okay, so I'm going to be using this fact later on to simplify. But first what I'm going to do is multiply the top and the bottom of my rational expression by the reciprocal of this denominator, because this turns the denominator into 1. So I've multiplied the bottom by 25 over b squared minus 25, and now that's equal to 1. Now when I multiply the numerator by that, I'm just going to rewrite that problem over here. I've got b plus 5 over 10 times 25 over b squared minus 25, which I'm going to express as b plus 5 times b minus 5. And now I can eliminate some common factors in the numerator and the denominator. I can eliminate b plus 5 and b plus 5. And 25 divided by 5 is 5. 10 divided by 5 is 2. So what I'm left with is 5 over 2 times b minus 5. And if you want to write that as 2b minus 10, be my guest. It doesn't matter. Let's take a look at what our restrictions are going to be. What can b not be equal to? Let's go back to the beginning of the problem. There's no b in the denominator right here, so we're okay. No b in the denominator over here. But then when we get to this step and we're multiplying by this reciprocal, we see that b is in the denominator and it can be equal to positive 5 or negative 5. So that is the restriction on my denominator, and that takes care of my answer also. And so this is how you simplify complex fractions. So to recap, in order to simplify complex rational expressions, the first thing you want to do is to simplify the top, meaning the numerator, and or the bottom, meaning the denominator, if necessary, with a lowest common denominator. Then you want to multiply the top and or the bottom by the reciprocal of the denominator in order to turn it into 1, so we have just one single rational expression. And never, never forget to express restrictions on your variable. You can take a look at pages 61 to 63 in your text if you want any further examples or explanations.